Before you guys take your test, I thought you may want to try a few review problems first. So the way I would suggest that you do this is pause the video. So check out the problem, pause the video, work through that problem, and then when you start the video back up, I'll go through an explanation of how you might attack the problem. So this first problem here, they ask you to graph that quadrilateral SHAY, and it gave you the coordinates. So I've already gone ahead and done the graph. So if you had a problem like this on your test, the first thing you want to do is make sure that you graph it on graph paper, and you kind of start from there. But I've already done the graph. So they want us to identify what type of quadrilateral it is, but we want to be as specific as possible. Well, before we can decide what kind of quadrilateral it is, some of the things that you'll want to find are going to be how long are the sides and what are the slopes for the sides. So if we label the figure here, S was here, H was here, A was here, and Y was here. So I'm going to just go side by side and first of all figure out what the lengths are. So if I go SH, then HA, AY, and SY. So I'm going to see how long each of those sides are. Well, SH isn't too bad because all we got to do is basically count it. So from 0 to 5, SH is just 5 units. From A to H, though, this is where we think about maybe making a right triangle. And doing the Pythagorean theorem to find that length. So this side is 3, this side is 4. So if I do Pythagorean theorem there, 3 squared plus 4 squared, I can figure out how long AH is. So in this case, it ends up being a 3, 4, 5 triangle. So HA is also 5. Then I'll do the same thing for AY. So this side is 3. This side is 4, so it turns out AY is also 5. And then finally SY. And it has a side of 4 and the side of 7. So if I do 7 squared plus 4 squared, square root of that, that's going to be approximately 8.06. Okay, so I start with the lengths. What the lengths might help me do when I start identifying it is, okay, did I have opposite sides that were the same? If so, then that tells me maybe I'm looking at a parallelogram. Do I have all the sides the same length? If so, well, that would tell me maybe it's rhombus, maybe it's a square. So it kind of helps me narrow down what type of figure I'm looking at. The other thing you want to find, though, would be the slopes. So let's see if I can find the slope for each of those same sides. Well, if we look at SH, we went up 5, but we didn't go over. Or in other words, we're really looking at a vertical line. So SH actually had an undefined slope. HA, we went up 3 and over 4, so it had a slope of 3/4. AY, we went down 4 to the right 3, so that's a negative 4/3. And finally, SY, we've gone up 4 and over 7, so I got 4/7. Now, how does slope help me? Well, slopes may tell me if I have some parallel lines, because we know if the slope's the same, they're going to be parallel. Well, I don't have any slopes that are the same, so I don't have any parallel lines. The second thing I look for is maybe do I have perpendicular lines? Remember, perpendicular slopes would be the ones that are opposite signs but reciprocals of one another. So 3/4 and negative 4/3, those are opposite reciprocals. So that means HA and AY are actually perpendicular. So that means that's a 90-degree angle. but that doesn't really give me any other information about other angles. So it turns out on this one, if I was going to try to identify it, we didn't have any parallel sides, so that eliminates the all the parallelograms. So the parallelogram, the rhombus, the rectangle, the square, all those are out. It also eliminates the trapezoid or the isosceles trapezoid. SH and HA were the same, and so was AY, but we didn't have a kite there because, remember, a kite would have two distinct pairs of sides that were the same. So it looks like we don't have enough information to say a whole lot more than just saying that this is just a quadrilateral. And that's as specific as we can get. We got 4 sides, that's about as far as we can go. All right, so you should be able to plot points like we did the other day, find all those things, lengths and slopes, and then most importantly, be able to use those results to make a decision on, okay, what kind of figure am I dealing with? All right, here's the next problem. So in this problem, notice some of the parts. We've got the fact that G is a midpoint because they mark these two pieces the same. H is a midpoint, so that means GH is a midline or mid-segment. So here's the information they're telling us. GH is 4x minus 3. And they're telling us IJ is 3x plus 14. And our goal is to figure out how long GH is. So again, maybe you pause the video, try to work this one out. Once you've done that, go ahead and start it back up. All right, well, the key to this is the fact that, remember we said the midline, or GH, should be half as long as the third side, or IJ. So you could attack this one of two ways. You could say, okay, well, if I took IJ, 3x plus 14, and I divided it by 2, that should give me the length of the mid-segment, which was 4x minus 3. So that's one way you could have approached it. Another way you could have approached it is said, okay, well, the midline's half as long, so that means if I double the midline, that should be the same length as the third side. So you could approach it either way, and in fact, really, if you started with this first equation, you would still get to that second equation by thinking about, I got to get rid of the fraction, so I'm going to multiply by 2, which means I have to multiply this side by 2, and so we get to the exact same place. All right, let's see what x is. So we're going to distribute maybe. Subtract 3x, add 6, and I find out that x is equal to 4. But remember, they asked for the length of GH. So I've got to plug that in. Well, if I plug in 4, I get 4 times 4 or 16, minus 3, the length of GH should be 13. And it might not be a bad idea to double check. Well, if I plug 4 in for x down here, 4 times 3 is 12, plus 14 is 26, and we got the result we wanted. We got the fact that 13, or GH, was half as long as 26. So answering this question, the length of GH is equal to 13. All right, so we should be comfortable and know about the midlines or the mid segments. Remember another fact we have going on here, which didn't come into play on this problem, but GH is also parallel to this other side of IJ. So that's another result, because the midline, when it connects into midpoints, remember, is going to be parallel as well. All right, one last example. This one, we're asked to use that figure, that picture. And in that picture, notice these two pieces of information are given. We're given the fact that angle Z is congruent to angle X. And we're given the fact that WZ is parallel to XY. Our goal is to try to prove that the two triangles are congruent to each other. So I'd like you to try to write either a flowchart or a two-column proof, I don't care which one, that would take that given information and prove the two triangles are congruent. So again, go ahead and pause the video. Go ahead and write out your proof. Okay, as you started writing in your proof, we always want to come up with a plan. So we said in order to figure out eventually that the triangles are congruent, we need to have, am I headed towards side, side, side? Am I headed toward angle, side, angle? Whatever happens to end up being. So let's go to our picture before we even start drawing out anything for our proof. Well, in our picture, some things that we can definitely mark. I'm guessing a lot of you started with a shared side, that reflexive side of WY. So that would be a good thing to mark. Anytime you see parallel lines, I start looking for angles that are the same. Well, one set of angles that would be the same would be this angle down here with this angle here, because they're alternate interior. Now I check and see, okay, do I have enough to say they're congruent? And it looks like I do because we have angle, angle, side in this picture. So now I'm ready to start my flow chart. All right, well, I have angle, angle, side, so I'm going to start with 3 ovals. And in those 3 ovals, some of the information I have marked. I have angle X and angle Z marked. And they were given. I've got the other set of angles, and again, I probably want to use 3 letters here. So I have X, Y, W. And Z, W, Y. And those were alternate interior. Now, as I'm writing that, I might say, no, wait a second. Alternate interior angles are not always equal. I had to know that I had parallel lines to make that statement. So the parallel line statement was needed in order to make that alternate interior angle statement. So I've got to add a bubble up here with the fact that WZ was parallel to XY, which was given. But more importantly, that led me to that statement. So I'm going to put an arrow there. I didn't need the fact that those 2 lines were parallel to say that X and Z were the same, so I don't need an arrow there. The third statement was that reflexive side, so WY is congruent to WY. That was true no matter what as well, so I didn't have to draw an arrow from the parallel lines for that one either. Well, those 3 pieces put together told me enough, or gave me enough information to say my proof statement. My proof statement is triangle WXY is congruent to triangle YZW. And we said that was an example of angle, angle, side. And again, if you want to write that with a 2-column proof, I'm okay with that. All right, so those are just kind of some review problems, some things to think about before you take your test. Now, one of the problems on the test, I just want to be clear on the instructions. When you get to the test, problem number 6, on problem number 6, they gave us some information. They wanted us to prove the 2 triangles are congruent in the picture. what you have to do is you're going to take all the statements and reasons that are up here, are all the parts of our proof. So you don't have to add anything to your proof or anything like that. But what you're going to do is you're going to rearrange those into an appropriate proof. For instance, every single bubble there is going to be rearranged into a new proof. I want you to actually rewrite that proof, though. Okay, so you're going to have a bubble, whatever that fact may be. You're going to have it lead to something else maybe, but you're going to literally rewrite that proof using each of the bubbles that are here. Okay, so all of these bubbles will be here. It's just a matter of you rearranging those into what would look like a nice proof. So you don't have to add anything to it as far as finding any statements or reasons. You're just rearranging the pieces and rewriting it. So your finished product should look like a regular old flowchart proof. So your finished product should be something like what we did here. I should see it as a proof, but you're just using the parts that are here. And for each part, the statement and the reason, they're matched up already. So it's not like you have to rearrange those statements and reasons. They're already paired up together. So sometimes people are a little confused on the directions there. So hopefully that helps a little bit.